Good day, stats students. So we're going to talk about Chapter 10 today, and we're going to have a bit of an introduction into talking about independent versus dependent samples because basically if you understand if you have independent versus dependent samples, then you know which section that you're in, if you're in section 10.2 or 10.4, and you know what type of analysis to do at that point. Now, before we get into independent versus dependent samples, I want to bring up one topic first. All right, that topic is that Chapter 10 is all about the comparison of two population means. All right, so you might be asking yourself, hold on, Doug, how can we have two populations? How can we have two population means? Doesn't the researcher just have one population out there, and that's it? And the answer is no, maybe not. All right. Maybe the researcher wants to just simply compare groups. Okay, let me give you an example. Instead of looking at the height of all University of Akron students, the researcher wants to compare the heights of all University of Akron males versus the heights of all University of Akron females. All right, and so in this situation, instead of looking at the entire population here, which is all University of Akron students, the researcher decided that there was some sort of categorical variable out there, and you might call it gender or maybe sex, but there's a categorical variable out there, all right, and we have males and we have females, and the researcher wanted to take that the different levels of the categorical variable and look at those different possible groups now. Okay. And notice here that there was still a quantitative variable, and the quantitative variable in this case was height. Thus we are looking at means because we do have a quantitative variable out there. Okay, so we have the two means for males versus females that we want to go ahead and compare. And so notice you have one categorical variable and one quantitative variable, and you compare the quantitative variable just on the different levels of the categorical. Okay. Now you might be asking yourself, could we have more than two groups? And the answer is yes. That would be what's called an ANOVA test, and that's in a different stats course, if you will. Okay, so we don't have to worry about more than two groups in this course. Okay, let's just worry about the two groups in Chapter 10, and all right, and study that for now. Okay. Let's get into dependent versus independent samples then. So notice I started with dependent samples. All right, so let's talk about that first. So we have dependent samples. What is that? Well, I think instead of trying to describe it, let me go ahead and give you an example. All right. And by the way, if you go to the commentary for Chapter 10, I think it's in section 10.2, you can see more examples with regards to this, okay? And so check it out if you still need a little bit of practice, all right? So here's example 1. You have exactly the same people in both samples, and thus you have exactly the same people in both populations. So you have this before versus after situation. So let me give you an example. You have the SAT scores before and after taking a course. So let's say that you have some students who took the SAT and didn't do well as they wanted to. And so they said, maybe we need to beef this up a bit, and I need to take a course. Okay, so they take a course, and hopefully they've done better. All right, on an individual basis. All right. Well, how do we study then if the course was effective? All right. So what we would do is, we would go ahead and study then on an individual basis the before and after score. So did the individual score 20 points higher or 50 points higher, or did they score 5 points lower? Okay. We want to know that on an individual basis. It only makes sense. Okay, and so you can actually have exactly the same people in two populations. And what are the two populations here? You have a before and you have an after. Before and after what? Taking the course. Okay, and notice you have a quantitative variable here, SAT scores. Okay, and you just have a before and after. Let me give you another example. Example number 2, you don't actually have to have exactly the same people in both populations. So let's say that you want to compare husbands and wives somehow. Maybe you want to compare husband and wives' annual salaries. All right? And so you have this natural pairing going on, husbands to wives, okay? So the way you want to think of this as far as dependent samples go is that you have this natural one-to-one pairing going on, natural one-to-one pairing, okay? And so what I mean by that is that you have population number 1 out there, then you have population number 2, all right, and this person right here, this thing, can be compared to this person or this thing over here, and only that person. It only makes sense to compare it to that person there, and then person number 2, only this person over there, okay, and so on and so forth. All right, and so you have this natural pairing going on. All right, and you have that for everybody in the population. By the way, it doesn't matter which one, this would hold true for either case, either the independent or dependent samples. Okay, it doesn't matter which one you call population 1 and population number 2. The analysis in the end will be exactly the same. And what I mean by that is that, and so you can, one person can go ahead and make population number 1 the husbands and population 2 the wives. Somebody else can make the wives population 1 and husbands population number 2. If they're exactly the same numbers, you'd get exactly the same results in the end. Basically what would happen is that all the signs would be different with the comparisons, but the interpretation in the end would be exactly the same. All right, wouldn't matter if you even made population 1 the after and population number 2 the before. It doesn't matter. Or make population 1 the before and population 2 the after. Taking that course. All right. Here's one more example. I had a student ask me. He was a bit of a gambler. He liked to bet on NFL football games, and I'm sure all of you have heard of a home field advantage, that a team that plays in front of their home crowd has a bit of an advantage, okay? Maybe for various reasons. And so he wanted to know, was there truly a home field advantage in the NFL? And I said, oh, okay, we can run a dependent samples case in that situation. Why? Because you have the home team score. Well, what is the home team score going to be naturally compared to? You're going to compare it to naturally the visiting team score. It only makes sense. Okay, you got this natural pairing. For this particular game, you had a home team, you had a visiting team. For this game, you had a home team, visiting team, home team, visiting team, so on and so forth. Okay, so dependent samples. So meaning the one sample is dependent upon the other one. Okay, and we mean and so meaning the people that are in the two populations, or the things that are in the two populations, they are kind of linked. Okay, they're dependent. Okay. How about the independent samples case? There's no one-to-one natural pairings going on here. Basically, everybody just gets thrown into groups, and the groups are compared, not individuals at that point. And so the example would be the example that I gave before, comparing University of Akron males versus University of Akron females. So think of yourself, your situation. Okay, let's say that you're a male. Is there a very specific female that you can be compared to, and only can be and that comparison is only good for versus that female, and vice versa? Is there, let's say that you're a University of Akron female, is there only one male that you can be compared to? I mean, it doesn't make any sense. There's no natural pairing that's happening. So I had a student one time. He raised his hand. He goes, it was a male, and he goes, I have a twin sister here. He goes, what about that? And I said, no. And the reason why is that, first of all, I get it that you might want to be compared to her. However, does everybody have a twin sister or twin brother? And the answer obviously to that is no. So everybody would have to have a twin in order to think about it in terms of that. Okay, and so in order to have dependent samples, everybody in the population must have this natural pairing going on. Okay, and if that's not the case, then we have independent samples where the samples aren't connected in some way, shape, or form on an individual basis, and they're just going to be looked at as in groups. Dependent samples will be in section 10.4, and what we're going to call that is a paired t-test. This has a lot of different names, this test, and we'll just call it the paired t-test. And you can see why we call it the paired t-test, because you have this natural pairing going on. Okay. Independent samples is actually section 10.2, and that's what we're going to start with first in the actual analysis, and that's what we call a two-sample t-test. That type of analysis. So let's do this. Let's see if you can tell if we're running independent or dependent samples for these next examples. So here's the first one. I'd like to watch some science shows on television, so that's where I'm getting these examples from. So the television program Brain Games did a study where they had 40 randomly selected adults drive a go-kart course, but the steering wheel actually steered the opposite way. If you turn the wheel to the right, the car actually turned left, and vice versa. So if you turn left, the wheel left, the car actually went right. Then they studied 40 randomly selected children from the ages of 10 to 12, so old enough to be in a go-kart, but they were young enough to not have their driver's license yet. And they drove the same course under the same conditions. The two population means were compared to see if a significant difference existed between the mean times to finish the course. Okay, so time, all right, was the quantitative variable. That means we can look at means, right? And we have two groups. We have the adults, and then we have the children. Okay, and they were all randomly selected, and so it's not even like the parents were compared to the children. Okay, that wasn't the case. So what are the two populations? We have all adults that were, so when I say all adults, they probably in this case they were already driving. That was the whole point, is that we want to compare adults that were driving versus all children, okay, that were not of driving age, and that they were old enough to get into a go-kart. Okay, now I kind of simplified the answer there, but you see what I mean. So is this an independent two-sample t-test, or is this the dependent study, and we're going to do a paired t-test? What do you think? So you got the children, okay, you have the adults. It's not parents versus the children. It was just randomly selected children, randomly selected adults. What do you think? Hopefully you said that's the independent samples case, the two-sample t-test. And we're just going to look at them in groups, okay? And by the way, the children's mean time to finish the course was significantly lower than the adults' mean time. And the reason for that is that the adults were driving for so long that that they had a tough time adjusting to this. Okay, they had a really tough time adjusting. All right, because their brain was so ingrained in hey, turn the wheel to the right, car's going to go right, so on and so forth. But the children were able to adapt very quickly because they were not driving age, and they said, oh, okay, so if I turn the wheel this way, that's what the go-kart's going to do. So anyways, it was kind of interesting. Here's a second example. So there was a television program called Mythbusters, and they did a study in which the host did a series of cognitive tests in which they were timed. Then all the hosts were sleep deprived for 24 hours. Afterwards, they were all tested again, doing the same type of cognitive test. And again, they were timed. The mean time before being sleep deprived and after were compared to see if even mild sleep deprivation increased the mean time to complete the tasks. Soon the results could be applied to all adults. Okay, so what are our two populations? We got all adults before and after sleep deprivation. Then, is this an independent or dependent study? Are we going to run the two-sample t-test, or are we going to run the paired t-test? Think about it. So here, we have the dependent samples, because we have exactly the same people, okay, and before sleep deprivation and after sleep deprivation, okay, and we have an actual pairing going on, okay. Now, if you aren't completely satisfied with my examples here, I have more examples, but it's in the commentary of section 10.2. So if you go to the commentary in section 10.2 for 10.2 and go to the where I have the questions at the end, there's more examples there with the answers. And so if you need more practice, take a look at those. All right, but that'll end our discussion with the introduction to chapter 10. Thank you for your time. Oh, by the way, it definitely took longer on average after the sleep deprivation. I forgot that. Okay, thanks.